this last video, I will explain the remaining part of the number, starting with a concept which says if square of any odd number except 1 can be represented with represented by sum of two consecutive natural number. So that has to be proved. Now let's say I am taking an odd number that is in general form, that is 2n plus 1, because if n belongs to natural number, for any value of n, this definitely be a odd number. Now I am taking square of that. So if I expand it, I will get 4n square plus 4n plus 1. Now you know, any consecutive term, the difference of the term is 1. This is the universal truth. Any consecutive natural number will have a difference of 1. So I keep this 1 in one bracket. So the remaining thing is, you can see, is 4n square plus 4n. That easily can be divided into two parts. One part will be in one bracket. Let's say I am keeping this part in this bracket. The remaining one part will be on the other bracket. So this will not give any difference if the term be anything, and that is differed by 1 only. In between there is so this can definitely be said that these are consecutive terms. So this is the requirement of the theorem, where any odd number square can be represented two consecutive natural number. Now I will explain it with the example. Let's say n I am taking is equal to 1. So because n cannot be 0, because I am excluding 1, because n only 0 that gives 1, so 1 will not follow this theory. So I am starting with n is equal to 1. So 1 says this is 3 square, this is 3 square. Now if I put 1 here, I will get first term is 4 and second term is 5. Match it. 1 square means 2 plus 2 4, and it is definitely differed by 1. So this follows the rule. 3 square can be represented as a two consecutive natural number. Now come to n is equal to, if I take 2, so this will give you 5 square, and if I put 2 here, 2 square means 4 into 2 8 and 4, that means 12, and definitely it has to be 13 because differed by 1. So 13 plus 12 is 25, 5 square is equal to 25. So this way, any number you take, it will follow the rule. So this, hence you can prove, you can say that this is correct. Moving to the next, finding square. So to find square, there are all total 3 methods. Generally we can find. First is visual. These are being named as visual method. Second is column, and third is diagonal. So in this, diagonal is still people are using and very friendly it is to use. Anybody can do, and it is very easy to understand too. This is also you can use because there is no limitation, but it is bit difficult than this. cannot say difficult, but for higher thing you have to calculate more. This is definitely can be neglected because this is very tough and very lengthy also. Okay, so and has a limitation up to 2 digit. You cannot go further. So I will explain one by one. In visual method, any square can understand can be represented in the form of square, a geometric square. So generally what I do, if I take 3 here and the 3 arms, the multiplication will give you 9. That I have shown you the dotted also, how it can be done. Now this is the further further analytic process of that to ease the calculation. How will I do? Let's say I am doing for now first understand the concept. If I divide this line in the form of A and B, where A not equal to B, or maybe A equal to and A greater than B, if I assume like that, so if I divide this in two parts, and you can understand these are the parallel line to the arms. So if this is A, this is B, and definitely all other the similar lines are of same dimension. There is no difference in that. Okay, as per the geometry, because these are the parallel lines. So this is definitely a square, and the result will be A square here and B square here. The remaining is a rectangle, and rectangle having same result if I multiply it with the length of the arms and length of the sides. Okay, so all total this will be resulted as A square. If I square it up, A square plus 2AB plus B square. Now my task is to divide the given number in this part. So if I assume that is I have to calculate 13 square, so it can be represented 13 plus 3 whole square. Now this is A, this is B. Now if I put the values of that, so definitely it will be 100 square. A square is equal to 100 square plus 2AB. If I take 13 to 260, and here I will get 9. So all total if I add, I will get 169. Rather if I do it 13 square, so I have to multiply 13 into 13, then I will calculate for the traditional multiplication method, I will get the same result. So this will ease your calculation somewhat, but I don't know for the higher numbers how will you act and how will you divide. That is depends on your capability and skills. So this is the one method. The second method is the column method, where I use the identity, the same identity, A plus B whole square is equal to A square plus 2AB plus B square, but the number is not the same way it will described. That means this is having a limitation of 2, so I will take any two numbers in a higher side where the number can be represented AB. Let's say A is equal to 5 and B is equal to 7. So AB is the number. It is not that A plus B will be, but I will identify. I will use this identity. How will I use it? I will make one chart, and it will be divided into 3 columns. Column 1, column 2, column 3. Okay. Now in column 1, I will put A square. Here I will put 2 into A into B. Here I will put B square. So first put the value. If A is 25, it will give you 25. This is 70, and this will give you 49. Okay. Now my first step is to mark the unit place of the last column, and this 4 I have to add there. So I will get 74. Now mark the unit place of the second column, the result of the second column, and this 7 has to be added there. Now I will get 32 here. Okay. Now all this, and again I have to mark this one. Now wherever there is a dash, I will straightway write here somewhere down all numbers one by one. Okay. 3249, and this will probably give you the, if I square up 57 square, so this will give you the result. So let's see 57 into 57 is coming or not. Let me check with the traditional method. 57 into 57, 49, 35 into 35 plus 4, 39, 35, 3, 28, 9, 4, 2, 3. So you can see the number comes. So this is the process of column. Just for the knowledge I am explaining. This is not very useful for you also, and you can use it for the sake of your interest, but otherwise it's not recommendable. The third one is the diagonal method, which is very useful. Useful in the sense you can use it for even any multiplication also, any product of two numbers apart from square. It will be used in same manner as used in for other product also. Let's say I am squaring up two digit number, let's say any number 38, let's say. So as because this is two numbers, I will divide into 4 coordinates, where I will put the number each in each coordinates. Similarly 3838. Now I will divide in diagonals with this same way as I am drawing. So in first two numbers, this will become the multiplication of these two. 3, 3, 9. So 9 has a one digit, so the first place will be 0, second place will be 9. Now I multiply these two. 3 8s are 24. So 2 will be there, 4 will be there. Now I multiply with this 3, 24 again. So this will be 2 here, 4 here, 8 8, 64. Okay. Now I will put some striking mark. Why I am putting, I will let you know. So along this line I have to add the numbers which is cutting each number. So the result, I will start with the downwards. So there I am getting nothing, so 4 will be there. There 4 plus 6, 10 plus 4. So 4 I will keep here, 1 will be carry forward. The 9 plus 2 is 11, plus 2 13, plus 1 14 here. Okay, and here nothing is there, 0. So I will get 1 here, because here I am carried, so 1 here. So if I do the square of that, let me check whether I am getting this number or not. 8 8 is 64, 4 will be, 6 will be there, 24, 30, 3 is a 24, 2 will be there, 3 is a 9, 2, 11. So 4, 4, 4, 1. See, this is matching. So this is the method, diagonal method. This is the third and last method, by which apart from square, you can use it for even any kind of product of any digit. Accordingly, because if you use for any means any numbers which are having 2 digit, 2, 3 digit, or any numbers of digit, if you multiply, let's say I am taking for example 1 2 3, 1 2 into 1 2 3. So in this case, how will you arrange that? You can divide this number in cells where 3 digit number will be here, or 2 digit will be here, or other way around. You can bring it in this fashion also, where you have to divide horizontally more numbers and vertically less numbers. Okay, so this also give you the, but the process is that you have to divide it diagonally, you have to put the number likewise, then you have to add according to the diagonal strikes where it is striking the numbers. Okay, So this is the let me check any other things remaining or not. No. So this is the end of the sessions on number, and in later class I will come with any other subject related to your academic. Thank you.